Before diving into the world of integration and differentiation and the complexity of equations, there are three key points we need to understand. The first point is that integration is concerned with finding the area under a function's curve. The second point is that differentiation is about finding the instantaneous rate of change of a function. The third and final point is, what does a function mean? We can interpret it as a specific behavior. Let's take an example. Suppose we have a car that accelerates in a sine wave pattern until it reaches a speed of 120, then begins to decelerate in the same manner until it comes to a complete stop. Now we have all three key points in front of us. The function represents the behavior of the speed or acceleration. The integral represents the area under the curve, which in this case corresponds to the distance traveled. As for the derivative, it represents the instantaneous rate of change, and since the function here represents speed, its rate of change gives us the acceleration. We noticed that there was acceleration until we reached the peak, at which point the acceleration became zero. After that, the acceleration began to decrease until the car came to a complete stop. So the process of differentiation or derivation involves calculating the rate of change at every instant. If we go to the peak, we find that the rate of change equals zero. Let's take 2 points, one at the beginning and one at the peak, and observe the rate of change as we bring the first point closer and closer to the peak until they merge. Let's focus on the rate of change, which is the slope of the line connecting these 2 points. We notice that it approaches a horizontal line, and the horizontal line has a slope of 0. The closer the 2 points are to each other, the closer the slope gets to 0, and that slope is the rate of change. This is why the concept of a limit exists in the world of differentiation. The definition of the derivative using limits looks like this. H here represents the distance between the 2 points along the x-axis. As h approaches 0, meaning the difference between the 2 points vanishes, we obtain the instantaneous rate of change. We can apply this to every point or every instant on the speed curve in front of us. As for the distance, it is represented by the area under the curve. We can go to any point on the curve, calculate the area under it up to that point, and the resulting area will give us the exact distance traveled at that precise moment.